Hello everyone, this is Rami Aluta recording out of my home office in Voorburg, the Netherlands. I'm a senior solution engineer working for Esri and supporting our global nonprofit network and European mapping agencies. I specialize in the geospatial analytics field with a focus on GeoAI and automation in the ArcGIS system. Today, we will see how we can, in no time and with only 32 training samples, perform a rapid damage assessment exercise, powered by the out-of-the-box deep learning tools in ArcGIS Pro starting version 3.3. Without further delay, let's jump to ArcGIS Pro and explore how can we accomplish this. I will see you at the end of the video. You might have heard of the devastating Hurricane Beryl that hit Grenada and its surrounding islands on the 2nd of July. It left a large number of families with partially or completely damaged homes. If we take a closer look at the damaged area bookmark in the imagery provided to us by Maxar, we will see the high number of damaged structures. As a rule of thumb, any features that you can see with your own eyes in less than 3 seconds, and we can see plenty of these in the image, you should be able to teach a deep learning model how to extract it. We will start our workflow with exploring the captured training data. I've already done this exercise for you. I'll switch on the layer and open the attribute table. I zoomed into it, so my attribute table is there. So today we are going to be training a SAMLoRA model, one of the newest foundational models additions to ArcGIS Pro. One of its core capabilities is applying transfer learning with a very small training dataset. And you can see that in my attribute table. I've got only 32 features, and you can see these 32 features up on the screen. They're classified into damaged and undamaged. And we know this is partially damaged, but nothing compared to this. So we took the privilege of working with those. For the exercise today, I'm going to be using three different tools. I'll start with export training data for deep learning, then move to train deep learning models, and finally classify pixels using deep learning. These tools can be found under the image analyst toolbox under deep learning toolset in the geoprocessing tools. So to start with export training data for deep learning, I'm gonna open my history and I can see that my input in here is my imagery that is sitting up there. I've got my output folder, the training data, which we've explored already, the class, which is damaged, undamaged, and I'll leave the tile size, stride size as default. We have different blog posts that explore these and explain what these parameters are there to do and how can they affect their training process. Finally, one of the very important things to keep in mind is the metadata format, and I'm using classified tiles because this is the essential metadata labeling that will be used with training deep learning model. I'm gonna go to my catalog and then expand my folders, look into my deep learning, and this is the training data I've exported. To have an idea, I'm just gonna add the layer and you can see how the labels can come in with what would they look like. So with that, let's remove these and move to the next step. So our training data is ready to be moved to training a model. And to do that, again, I'm going to look at export training data or at train deep learning models. If you can look here, it's around 9 minutes 38 seconds to process this. So hence I'm looking into my history, but let's just explore the parameters a little bit. So we can see on the screen, I've already have my training data that we just explored and put it in there. This is certainly an error as I already have something in the folder. All I need to do is change to V1 for instance, and this should go fine. I'm running on epochs of 40 epochs over the model. In my last run, I figured out that I might be able to enhance that a little bit or the training learning rate. So maybe exploring with 50 could be worth it. The most important one is the model type. I'm choosing SAMLoRA for this workflow. and the class balancing is true as I have a little bit more damaged than not damaged data. For the data prep, I have a batch size of 8. You can increase or decrease this based on your GPU capability. The validation left as 10%. And finally, I'm going to use the VIT-H, which is the backbone model of high neural networks. If I look into my information here and scroll down, I have the basic, which is a base neural network size. Then I have the fit large, which is the larger neural network size, and the H, which is the huge neural network size. So I'm going for the huge one as I have a very minimal training data set. If I ran this as I explained earlier, it will take 10 minutes and I can look a little bit at my messages. If I open this guy, I can see that it took the 40 epochs and the accuracy starts at 2% and keeps climbing up to reach 89.8%, so approximately 90% accuracy in 9 minutes. So with that, the last step was to take this model for a ride, and with that, we're going to be using the last tool, which is classifying pixels using deep learning. This took around 1 minute, 8 seconds. So I'm going to go ahead and open this one to explore the parameters. So we can see that our input raster is still the same input raster. My output raster dataset, which is the output of this model, is the undamaged buildings. And you see that this is already in here. So I'm going to zoom to that layer just to show you that I work on a different extent, the damaged extent that we explored at the beginning of the video. Please note that for the inferencing exercise, we will be using a different area than the one that was used for training. My model definition is the one I just trained, which is damage assessment model SAMLoRA. And then batch size is left as default and padding as default. All I need to do here is train on this extent. So I'm going to click the current display extent here to make sure that I have the area that I want to inference. And I run this. And if I do that, as I've mentioned, it takes a minute. And you can see that the model is really coming back with very useful information. It's actually, these are not false positives even. These are the damaged, shattered parts of the buildings that came with the hurricane. So it's really good results from that perspective. I'm seeing those that are mostly damaged, partially damaged. This is, yeah, it's barely as on the sides, but the model can really help us create a very fast damage assessment. We can see there's a little bit of false positives. One is here, one is there, but that's expected. It's only 30 training samples, and this is in no time. So we're not having any data. This should be able to make a difference for you. I hope you found this demonstration useful and you will be able to apply similar use cases utilizing the power of SAMLoRA in your ArcGIS deep learning workflows. Thank you for watching and bye for now.